In this video, we're going to be talking about the encryption protocols that you're going to encounter in this course. So there's really two encryption protocols you need to know about in this course. The first one is SSL, which stands for Secure Socket Layer. And the second one is TLS, and that stands for Transport Layer Security. And we'll talk about them in a bit more detail on the next few slides. But let's start with the Secure Socket Layer and what it is. It's essentially a protocol which was invented in the 1990s with the introduction of the internet, and it became the industry standard in security technology for establishing an encrypted link between a web server and a browser on a client machine. It was much more secure than just the previous method, which was to send plain text over the internet, because it used symmetric and asymmetric encryption techniques to secure the data that was being transferred through the protocol. And you probably know it through using web browsers. If you see the green padlock at the top of your web browser, that shows that SSL style encryption is being used, and it's for that purposes. It's used for any sort of transmission of secure data. So for example, bank transactions are a really good example, or financial transactions, or logging into secure areas on a website, logging into your email, particular types of web browsing. I mean, now most of the websites on the internet are encrypted, and they're said to be encrypted using SSL. But actually this is not true. SSL has been superseded, and it's been superseded for about 18 years now, maybe longer. And it's been superseded by something called TLS. Yes, so TLS has been used for pretty much the whole time you've been alive. It was created in 1999 as an upgrade to SSL 3.0. So essentially it is still SSL, it's SSL 3.1. But it's much more secure than the former SSL, because it prevented man-in-the-middle attacks. Now these are where people pretending to be the server or the client can intercept some of the data and add their own authentication to it. But it prevents man-in-the-middle attacks through maintaining data integrity, i.e. so that the data is the same when it leaves the client and when it appears on the server, and vice versa. And it also applies additional layers of security that wasn't previously available in SSL 3.0. There's two layers in TLS that you need to know about. One is the handshake protocol, and you know about this before. We've talked about handshakes in other sort of aspects. The handshake essentially creates the session between the client and the server machine. It authenticates to make sure that these machines are who they say they are, and it exchanges the keys that are required to send secure messages. The record protocol, on the other hand, deals with the messages. So it takes the message that's going to be sent by the client, for example, and it divides it into manageable blocks. Now, it's also used in the server side, the record protocol, for reassembling any incoming messages from their blocks back into the message. The record also applies something called a MAC to outgoing messages, and that is used to verify the incoming messages for the data integrity. And it's also involved in encrypting and decrypting the messages using a secure form of cryptography. So, what you should have learned in this video is that SSL and TLS are essentially in the same family. TLS is the more up-to-date version of SSL, and it improves on SSL by ensuring that the integrity of data is maintained, and it also allows for an additional layer of security that SSL didn't previously provide. So let's look at an example of a handshake protocol. So in this example, we have the customer on the left and the server that it's going to communicate with on the right. So the client's on the left and the server's on the right. And when TLS or SSL is used, the first thing that happens is that a handshake protocol takes place to create the session. And so what happens is the customer computer says to the client, it says to the server, hi, let's set up a secure SSL session, and then the server sends back a message saying, yeah, hi, here's my certificate. Okay, and this makes sure that the customer can ensure that the certificate's valid and it's been signed, digitally signed by someone that the user trusts. Okay, so it could be like a bank, like Halifax or something like that. And so once that's been established, the customer says, okay, hi, here's my one-time encryption key for the session, okay, which has been encrypted using the server's public key, which came back in step 2. Once that's happened, there's a communication between the two, okay? So the server decrypts the session key using the private key and then establishes this secure session with the customer. And that is an example of the handshake protocol.